Welcome back to Linear Circuits. This is Dr. Ferry. This lesson is on the voltage divider law. The objective is for you to be able to use the voltage divider law on a circuit that looks like this, where we've got two resistors that are in series with one another with a voltage across them. We're going to be building on the idea of Ohm's law as well as resistors in series and how they combine for equivalent resistance. Well, the voltage divider law for this circuit is stated right here. The goal is to be able to find the voltage right here. And we use the name voltage divider law because the voltage over here of the source is going to be a combination of what the voltage drop is across this resistor as well as the voltage drop across this resistor. Let's go ahead and derive it now. Let's define the current here, I. And what I'd like to be able to do is solve for V sub 2. So let's first combine these two resistors. So if I redraw this circuit, combining the two resistors, I have R1 plus R2. Now this I is now a little bit clearer to determine what it is because I can use Ohm's law. And I have I is equal to V sub S over R1 plus R2. Now going back over here, I've got I going into this resistor, and so V2 is equal to R2I. So if I just substitute in here, V sub 2 is equal to R2 times I, which is R1 plus R2 in the denominator times V sub S, I get this expression right here. Now, I want you to solve this problem. Given this expression, what if I want to solve for V sub 2 with these variables right here? Okay, in this particular case, we've got the resistor over the sum of the two resistors. So remember, it's R2 over R1 plus R2. And so we've got times V sub S. We've got 200 over 400 times V sub S, which is 10. So we've got 5 volts. And actually, it makes sense over here. If this is 10 volts and these are both 200, that means that I've got an equal amount of voltage drop between these two, across each of these resistors. So each one has 5. Now, if I had different numbers, say if R2 is equal to 100, then V sub 2 would be equal to the 100 over the sum. Now the sum is 300 times 10, so it would be 10 over 3. And that would mean if this resistance goes down, there's a smaller voltage drop across here than this one. So remember, it is the resistor over the sum of the two resistances. Now, I want you to recognize when to use the voltage divider law. We looked at that simple case before, simple circuit, and it was pretty obvious. But you can also use the voltage divider law in these cases. Right here, I've got a voltage in parallel with a resistor, so that means the voltage from here to here is still V sub S. If it's still V sub S, then I can apply the voltage divider law across here where this is V sub S. So this resistor doesn't impact at all what this voltage is. Now looking at this case, how do I use the voltage divider law here? I want to find what V sub 3 is. Well, in order to do that, I'm going to have to combine these two resistors. And once I do that, I would replace it with this. And this would still be V sub 3. And this would be V sub 1, V sub S. But now this time, it's the R2 in parallel with R3 combination. So I combine those first, and then I apply the voltage divider law. Now looking over here, I've got a really kind of messy circuit right here. And suppose I want to find this voltage, V sub 2 right here. And I know what this voltage is right here. Well, I don't care whatever else is going on in this circuit. If I know what this voltage drop is from here to here, then I can apply the voltage divider law right here. So in this case, V sub 2 would be equal to R2, that resistance, over the sum of the two, R1 plus R2, times, in this case, 2 volts. We're going to do another quiz here. In this case, it's a little bit messier circuit, and I want you to find what Vout is. Now the solution, again, I've got this voltage which is in parallel with these two. That means the voltage from here to here is 20 volts. So I don't care what these resistors are here. What I have to do is find Vout. Well, Vout, the voltage divider law is only with respect to 2 resistors. So what I want to do is combine these two right there, and that is equal to 4 ohms because they're in series. So now what I've got is equivalent of 20 volts going into 4 ohms and 4 ohms over here, and Vout is across here. So this is a case where I've got 2 resistors that are the same. That means Vout is going to be half of the original. That's the solution. To summarize, the key concept here is very basic. It is simply the voltage divider law, which is given right here. And we look at that for this basic circuit, but we've shown how you can apply that to a little bit more complicated circuits as well. All right, thank you, and I hope to see you online asking and answering questions on the forum.